Welcome to my lecture, and in today's lecture we are going to discuss about the Laplace transform of integrals. So we state the formula by a theorem. So let f of t be a piecewise continuous on 0 to infinity and be of exponential order. Then the Laplace transform of 0 to t f tau d tau equal 1 over s L f t, which is 1 over s f s, with s greater than 0 and s greater than alpha. So now if you talk about the inverse, so L inverse, Laplace inverse, Fs over S is equal 0 to T f tau d tau. Okay, so now let's find the inverse of this one. L inverse 1 over S over S square plus 9. So we try to apply the previous formula, so it will write it as F S over S, which is equal to 1 over S over S square plus 9. So if you compare it, we'll get Fs is equal 1 over S square plus 9. And Ft is equal L inverse Fs, which is L inverse 1 over S square plus 9. So which is 1 over 3 sine 3. So now we are going to apply the this formula for integral. So this is equal 0 to t f of tau d tau. So in this case, it is 0 to t 1 over 3 sine 3 tau d tau. So the integration is minus 1 over 9 cosine 3 tau, and limit is 0 to t. So if you simplify it, you will get it 1 over 9 minus 1 over 9 cosine 3t. And this is the now next lecture we are going to discuss about the shifting theorem.